Hello, I'm Dan Ridley-Ellis and I'm going to give you a very quick overview of the research that we do in the Centre for Wood Science and Technology at Edinburgh Napier University. There are two closely connected centres, a Centre for Wood Science and Technology and the Centre for Offsite Construction and Innovative Structures, and there is a two-way feedback loop between the two. In Wood Science and Technology, we're interested in the properties of wood and what properties are needed for different uses and how those properties are influenced by the way that the trees are grown and processed. And in Centre for Offsite Construction and Innovative Structures, they're interested in using wood in construction in more interesting ways. And we provide the basic material information to COCIS, and COCIS provides the information about the properties that matter and how the wood is being used so that we can improve our research in CWST. In CWST, it's wood properties that are right at the core of everything that we do. And we're interested in everything from the small scale, the molecular and the microstructure of the cell wall, all the way up to the tree, forest and country level. And the reason for that is that it's the really small stuff that influences the wood properties at the macro scale, the things that matter for most of the things that we want to make out of wood. And those are influenced by the ways that the trees grow, the environment and the forest management, which are a tree, forest and country level thing. We're interested in the whole wood value chain, from tree breeding, forestry, harvesting, processing, because all those things influence wood properties. And lately also looking at using more recovered wood for higher value products, and also using a wider range of species. Firstly, to increase the resilience of the forest against pests and diseases and climate change and all that stuff, but also thinking about increasing the resilience of the forest and timber industries too, to those kind of disruptions. And we're interested in all kinds of manufacturing, grading, non-destructive technology, and we're interested as well in standards and policy and education and training, which is really important because it's a core part of the knowledge transfer and getting the knowledge of research into the hands of the practitioners who really matter. Now, we're interested in all sorts of ways in which the forests can influence our everyday lives, the economic, the social, the cultural and the environmental. But today I'm going to talk mostly about forests as a source of materials, and principally as a source of materials for the construction industry. Now, this kind of research involves fieldwork and a lot of laboratory testing. So we do have a facility in the university where we can do the basic kinds of tests that are required to underpin the knowledge of construction timber. We've got conditioning chambers to condition the wood to the right moisture content for those standards. We have a wood workshop for processing those test specimens. And through partnership with Forest Research, we have access to a timber drying kiln. And through partnership that we have with industry, our stakeholders and our research supporters and our collaborators, we also have access to industry facilities too, which is particularly important and very, very valuable. We're interested in the whole value chain, all the way from tree breeding and selection and the implication of that work on timber properties and suitability for different uses, all the way down to the production of dry, graded structural timber or non-structural timber from the sawmill as it passes on to the secondary processor, the fabricator or the end user. And at each step there are opportunities to assess the value of the wood, the properties of the wood, to segregate the material to the different markets, to do the grading and the necessary quality control. And although none of the fibre is wasted, we work to make sure that none of the value is wasted so that the wood goes to the right kinds of markets. So talking about non-destructive technology, we use those on standing trees to understand the timber quality and the way that trees grow. And we use them also on the sawn timber, a variety of different technologies, but it's acoustics that we're finding the most useful, time of flight on standing trees and resonance on the sawn timber. Over the years we've tested a lot of timber and we have very good knowledge of our main commercial species, Sitka spruce and Norway spruce, and a lot of information too about larch and Douglas fir. We've also lately been looking at so-called minor species and alternative species. These are things that are being considered for wider planting in the forest to increase resilience against pests and diseases, climate change, firestorms, etc. And we've been looking at the properties of those and what value chains they might go into, and particularly comparing them to spruce to see if they can be mixed in with the spruce resource. And the spruce grades very well to C16, which is a useful construction grade of timber. The larch and the Douglas fir grade to slightly higher strength classes, but even the spruce can go to higher strength classes if desired. Now with these other species we don't quite have enough information yet to underpin grading, visual grading or machine grading, but we do have a rough idea now of the properties. We know that many of them are quite similar to Sitka spruce, and even the ones that might not make C16, they are still potentially useful, as you can do many interesting things with lower grades than C16. Talking of grading, we have been involved in a lot of the work that underpins the machine grading of UK and Irish grown timber, the spruce, the larch and the Douglas fir, and most of the structurally graded spruce produced in UK and Ireland is produced with machine grading settings that we have had a part in developing, and we've used our wood properties research to improve those settings, to improve the yields for the producers, and also we've increased the range of machines that producers can use in their sawmills. If you're interested in finding out more, a good place to start is to Forestry Commission Forest Research published research notes, one on Sitka spruce and one on 4 of the alternative species, Norway spruce, western hemlock, western red cedar and noble fir, and hopefully there'll be one produced fairly soon as well on larch. For structural timber, the 3 properties that we care about the most are strength, stiffness and density, and most of our research has been focused on those, but there are other things that matter. We've also been looking at, for example, distortion, drying distortion and moisture movement. All those things are influenced by the way that the trees grow, and foresters in particular have a very large influence on wood properties. It's not just about the species, it's about the growth area, the environment, the location, but also the forest management and the forest type, things like the initial planting, the thinning, the rotation length. They all have influence on wood properties, and our research has been looking into that to guide forest management for different objectives for different products. And we've also been looking as well at some of the processes afterwards, the handling and the processing of timber, and how those can also influence the wood properties for better or for worse. Now there are a lot of misconceptions about wood quality, and particularly about the quality of timber grown in the UK, and I just want to take this opportunity to squash a couple of them. So I'm going to show you data from testing, a very large testing program that we did on tiling battens. Non-structural timber, but mechanical properties are still important. We sampled a lot of wood, almost 900 pieces grown from UK and Ireland, sawmills from different locations. As required by the standards, we test these in bending with the worst defect, what we think is the worst defect in the middle of the span. And for these very small cross sections, the knots can take up quite a large proportion of the cross section area. Now, a lot of people think that the ring width corresponds to the rate of growth of the tree, and that the faster the tree grows, the less dense the wood is and the less strong the wood is. Those are misconceptions. Ring width is in grading standards as a predictor of density, and it doesn't work for all species, but it sort of works for spruce, but it's not a very good correlation. So even ring width for density in spruce, the correlation is not as strong as people think. And it's a similar story with the knots. Even for these small cross sections where the knots are very big in comparison to the thickness and the width of the timber, the correlation between the size of the knot and the strength is quite weak. Knots are not that strong a predictor of timber quality, and the reason is there are lots of things that govern timber strength, lots of things that you can't see, and even when you have knots, the correlation between the strength and the knot size might be an indirect correlation to do with tree growth and other aspects that influence tree quality. Now, the other thing that I want to point out is that in this particular example here with larch, the stuff that we put into the C16 grade is considerably stronger than it needs to be for C16, and both are considerably denser than they need to be for the strength class that we put into them. So when we put timber into these commodity grades, we're actually underutilizing the true properties that they have. And if you're grading timber for a particular use, for a particular customer, or perhaps for something that you're building yourself, you can make use of these extra properties. So there are things that you can do with grading that are increasing the efficiency of the material use in buildings and making better use of the resource that we've got. And we do need to rethink the way that grading is done, because at the moment we can't really regrade timber that's been taken out of a building in deconstruction or demolition, because there are no ways of regrading timber and no ways of grading timber if you don't know the species and you don't know the origin. So we've got a project that's been going now for a couple of years called In Future Wood, which is looking at circular economy for construction timber in buildings, about using designing for reconstruction and using those materials from existing buildings in new buildings. And the work package that we've been involved in is the one that's looking at grading methods for recovered timber. So this is what we can do at the moment. You can take timber from normal mainstream forestry and you can grade it, and then you can process it and you can make buildings from it. But it's actually quite difficult to assess the properties of the timber once they're in situ for renovation and repair. And it's almost impossible to really grade the timber again once you've taken it out of a building and you want to reuse it. So at the moment, although a lot of timber is recycled, it's being used in lower level products, still useful products, but lower level products like panel products, like OSB, like chipboard. And what we want to be able to do is take that timber from a building deconstruction and to be able to grade it and use it again in its current form, whether that's a beam or a column or a CLT panel or a glulam. We want to be able to grade it again and use it safely in a new building. And actually solving that problem will also help with using a wider range of species in our construction as well. So that will help get those minor species, those alternative species, into the higher value markets and into construction. That's all I've got time for today, but I would like to leave you with one final thought. I think that the best first use of wood is the living tree. And I would like to find ways of using trees to solve the kinds of problems that we solve right now with manufactured products made from wood or other materials. So are there ways, better ways that we can use trees in the built environment as part of the built environment to solve built environment problems? Should engineers and other built environment professionals understand trees better? Anyway, that's my thoughts. Thank you very much.